The next crew handover on board the International Space Station is going to be a first of its kind. Since the end of crew transfers using the space shuttle, one of the station's three-person Soyuz crews has departed and left the other trio alone on board for a few weeks until the next group arrived. But not this time.
Nyberg, Luca Parmitano, and Fyodor Yurchikhin, they won't depart before the next crew arrives because that next crew is bringing up the Olympic torch.
We're going to be handing that Olympic torch to the Soyuz 36 crew, who will take it out on a spacewalk 2 days after we arrive.
That's not the only EVA task. There are jobs to be done to prepare for the upcoming arrival of the new Russian multipurpose laboratory module, too.
As you know, the new module is going to arrive to the station pretty soon, and the Russian segment has to be ready for that. So we need to replace a couple of antenna, hardware, we need to reconfigure COM cables outside the station. So these are the main tasks.
But the highlight of the spacewalk will be the activities with the torch.
They will then hand it to the Soyuz 35 crew, who will then fly that Olympic torch back to Russia. So it's kind of like our own little relay going on up there.
Olympic Games is an event that people from all over the world get together in one place and extend friendship through sportsmanship and excellence in sports. So it really fits our vision and goal of International Space Station.
That goal is to conduct science research that's not possible on Earth, and to learn what it will take to protect the human explorers who will make voyages of discovery beyond low Earth orbit in the years to come.
We need such flights to understand how to make a long-term existence of a human being in space safer.
So the crew members are test subjects for dozens of experiments to quantify the physical effects and test countermeasures to reduce or reverse those effects. For example, scientists are working to find out if certain foods can stop the loss of bone mass.
That's where we're looking at the ratio between animal proteins and potassium and how that affects bone loss. And so the idea is that if we can figure out what that right ratio is, we might be able to minimize the bone loss through just nutrition.
We will be measuring our physiological data related to the changes in the eye and the brain due to the change in the intracranial pressure in the microgravity. And by consistently gaining or measuring this kind of physiological data on our eyes and brain, we will be able to find out exactly what other causes are for the eyesight change in flight.
For another example, the research isn't just on the physical effects of being in space, though. There are experiments on the psychological ones, too, which could have applications here on Earth.
But if we're studying psychological aspects, they can be used not just in space exploration, but can be propagated and applied to human relations in general, and are much more in demand in various areas of our human activity, human life.
The station is also home to science in other disciplines, which are taking advantage of the unique environment in low Earth orbit.
For example, there's MAXI, which is looking at cosmic X-rays, and they've had some very interesting results. In fact, I think they were able to help detect a black hole shredding a star, and so that's just fascinating.
If we grow a crystal on board the station, the crystal will be of perfect shape. Crystals are used in the laser industry, in pharmacology, and huge protein molecules, which are very important in healthcare.
We're also looking at how pathogens interact with cells in a micro-G environment. And then on the other side of that, we have experiments where we're looking at how things burn, how things combust in space, so we can better understand why things ignite, how things burn, and then better understand how to keep materials from burning in whatever the situation may be.
Station crew members will attend to a whole range of science experiments during their stay on board. They've also trained for planned and potential spacewalks, and to receive shipments of supplies in a variety of cargo vehicles. By February, they'll be ready to watch some of another international gathering, the Winter Olympics in the Russian city of Sochi.
These two projects are devoted to the improvement of the communication, interaction, cooperation, people, different countries, different cultures. That is why the Olympic Games and the station are very much alike in this sense.
Expedition 38 gives way to Expedition 39 when Kotov and his Soyuz crew return to Earth in March, and Wakata takes over, the first Japanese astronaut ever to command the International Space Station.
Japan is very happy to have this opportunity to have ISS commander from the Japanese Astronaut Corps. It's a big challenge for me, and I'm just fortunate to be able to learn a lot from my previous ISS commanders and shuttle commanders.
Wakata's crew will grow by 3 when another Soyuz arrives a few weeks later, carrying NASA astronaut Steve Swanson and Russian cosmonauts Alexander Skvortsov and Oleg Artemyev. Those 6 crew members will work together until Wakata, Tyurin, and Mastracchio head home in May, having made their contribution to achieving a dream of humankind.
We want to go out and see what's out there. We want to know more about things, and we can't just do that through robotic systems. We have to send people to see things up close and personal. So I think it's very, very important to get folks into low Earth orbit. It's very, very important to get folks beyond low Earth orbit. And this is just one small step in that long, long journey.